Hello and welcome to Maths with Jacob. This lesson will focus on problem solving, work in reverse. Some problems give you a number of steps which lead to a final answer. Your aim is to find the information which is relevant to the beginning of the problem. Start from the information given at the end and work in reverse to find the missing information at the beginning. Example 1. Tom is 1/3 of Bill's age. Sally is 5 years older than Bill. If Sally is 65, how old is Tom? So on the right we see the three people, and we will now do the working. Now here they are, Tom, Bill and Sally. Now the problem says that Sally is 65. So here we write 65. Sally is 5 years older than Bill. That means Bill must be 60. Tom is 1/3 of Bill's age. 1/3 of 60 is 20. So there's a perfect example of how you work backwards. Example 2. I think of a number and add 3 to it. I multiply this answer by 4 and get 32. What was the original number? Okay, so the final answer, after we do all our calculations, right, the final answer, we'll do A for answer, equals 32. So that's at the end. Now, it says, I multiply this answer by 4 and get 32. So basically, if I go 32, of course we're working backwards now, and I divide that by 4, okay, that gives me 8. Okay, so we're getting closer. Then it says, I think of a number and add 3. So the number that we thought of, after we added 3, we got 8. So all we do here, 8 take away 3, and the answer that we started with, that we thought of, was 5. Mary baked some cupcakes. She ate 2 of them and sold 8 of them. If she had 12 cupcakes left, how many did she bake? Okay, so she had 12 left, and you can see them up there. Let's see if we can do some running writing. Oh, that's pretty good. Okay, she had 12 left. Now, it says she sold 8 of them. So, 12 plus 8 equals 20. Okay, that's before she sold any. She had 20. She ate 2 of them. So 20 plus 2 equals 22. And that's how she started off, with 22 cupcakes. Now you can actually start from the beginning here and just go through, and you'll find you'll get the answer at the end. But that's another perfect example of how we work backwards. A bacteria population triples itself each day. If there are 162 bacteria on the 5th day, how many bacteria were present on the 1st day? Okay, so we have day 1, day 2, day 3, day 4, and day 5. Now, if we start at the back, so we'll go right to the end, and we have 162 here. Okay, now it says it triples, so from that day to that day it tripled. So if we divide 162 by 3, that gives us 54. You divide 54 by 3, that gives you 18. You divide 18 by 3 to give you 6, and you divide 6 by 3 to give you 2. So on the 1st day, there were 2 bacteria. Example 5. On day 1, there was 1 flower on the pond. The number of flowers doubles each day. If the pond is completely covered in 50 days, how long did it take for the pond to be half covered? So basically, on the first day you have 1 flower, the second day 2 flowers, the third day 4 flowers, the fourth day 8 flowers, and so on until you get to 50 days, okay? So 50 days, what's happened? The pond is fully covered. Now, if the pond is fully covered in 50 days, what do you think happened on the 49th day? Because it says the number of flowers doubles each day. So on the 49th day, okay, which is 1 day less, the pond was half full. Okay? So the pond was half covered the day before, because from 49 to 50 it doubles. And if it's half covered and it doubles, that means it's fully covered. So how's that for a tricky little answer? So 49 is the answer. So there are some perfect examples of how you can work backwards to solve problems.